you've watched my videos before, you might know that I really enjoy coming up with names for things. Whether it was Methanum, Star Death Nebula, Astrobiogeography, or just the last video, Cry Asteroids, whenever I see something without a widely accepted name, I can't help but invent my own. Of course, I'm perfectly aware that this is a little immature, and I know full well that none of the words I come up with will ever make it into mainstream use. Well, that is except for one time. One time I got my hopes up and really let myself believe I might be able to name something. A planet. You see, a while back I made this video exploring the biology of planets like Kepler 186f. But after saying Kepler 186f over and over and over again, eventually I figured, why don't I just give this planet a name? With over 5,000 exoplanets discovered and more coming in every day, even the most prospective worlds, Kepler 186f, TRAPPIST-1e, Ross 128b, Gliese XYZ, all have yet to receive any more than a series of numbers and letters. My frustration with this naming system is what led me to emailing somebody at the International Astronomical Union, who, as we learned from the last video, are the ones in charge of these sorts of matters. And I started out by simply trying to explain who I was and what I was trying to do. I sent this email at 9:37 a.m. and I kid you not, by 10:04 I had a response. Hi Kaylin, thanks for your message. I have forwarded it to one of my colleagues who is involved in celestial names. We have worked together on this topic, so we will discuss it. Stay tuned. All right, that's what I like to hear. The fact that my proposal wasn't flat out rejected already gave me a lot of hope that Kepler 186f might soon be an outdated term. So I stayed tuned, and pretty soon I got another email from somebody else at the IAU. This time they introduced themselves as the chair of the IAU Working Group on Star Names and was co-chair of the IAU 100 Name ExoWorlds public naming campaigns, which, holy crap, sounds like exactly the person I want to be talking to. And what they wrote next blew my mind. I should mention off the bat that I've enjoyed some of your videos before. I love astronomy, geology, maps, etc. A lot of the topics that your videos cover. I was looking on YouTube and I think the first I encountered was the geography of the Ice Age, so thank you for producing these. I can't believe it. The chair of the IAU Working Group on Star Names likes my videos. This was music to my ears. I had a man on the inside, and by now I 100% believed it was possible for me to name this planet. But if you couldn't guess, along with the good news came some bad news. At this point, the IAU is not accepting individual proposals for proper names for exoplanets. Womp womp. Yeah, so looking back on it, obviously I couldn't just write 2 emails and name a planet. That's not how these sorts of things work. But I think the fact that I had myself convinced that it was possible is what made this whole experience all the more heartbreaking for me. But that's not all my new friend had to say. He very much agreed with the points I'd brought up and went on to explain the whole process for me, the thinking behind all their decisions, and finally he said this. Unfortunately, some of my other colleagues are backwards looking with respect to naming. The exoplanet community is used to the alphanumeric designations. New names add confusion, complaints which could easily be applied to asteroids and planetary satellites but don't stick. But I simply can't imagine a future where within a decade or two we don't simply know of these famous systems by elegant proper names. They are worlds, not file names, and the names can help inspire the next generation of astronomers better than any acronyms and numbers can. I couldn't have said it better myself. Overall, the person I had the privilege of connecting with really impressed me, and I feel like their thoughtful response gave me a lot of insight into the inner machinations of an organization like the IAU. This is especially true for the final piece of advice they gave me. Be on the watch for future IAU naming campaigns. campaigns. So that's exactly what I did. I sat on this idea, I sat on the connections I had made, and I sat on all the thoughts running through my head. I sat and I waited. I waited until August of this year when suddenly Name ExoWorlds 3 was announced, along with a new batch of planets approved to receive names. Though this time the stakes were even higher. Now, with the James Webb Space Telescope fully operational, pretty soon it'll take aim at a slew of nearby exoplanets and study them closely. Over the upcoming year, these 20 objects will become the most well understood exoplanets to date, and thus have been deemed worthy of names. It looks like this might really be my chance to name something, like for real. So please humor me as I walk us through what the process of naming a planet even looks like, and maybe by the end of this we can work together to leave our mark on astronomy. Okay, so our first step is to look at the list of planets the James Webb Space Telescope will be looking at. Now, obviously, I can't name all 20 of these. In fact, I'm only allowed to submit one entry. So what I have to figure out now is which of these 20 planets do I want to try to name. Though I think I speak for everybody when I say I'd rather name something that ends up being like really notable. Like either it has alien life or maybe just like an interesting geography. It'd be really cool to see the name I came up with in like the news and stuff. So what I'm gonna try to do is use what I've learned about exoplanets already to figure out which of these 20 planets has the best chances of being notable. Which, at least in my opinion, means finding the planet most capable of harboring life. To start us off, if I've learned anything from my past videos, it's that the most telling data point we often have on exoplanets is their mass. Building on that, we've also learned that objects between half an Earth mass up to 5 Earth masses tend to be terrestrial planets like our own. Any more massive than that and you exceed super Earth status and fall into mini Neptune territory. Before long you become an ice giant, then gas giants, and eventually brown dwarfs, none of which seem to be very lively places, if you know what I mean. That being said, like I brought up in a previous video, while these larger planets themselves may be poor places for life, the many possible moons each one could have taken into its orbit may very well make exomoons an equally likely place to find alien life. But, well, this isn't a contest for naming exomoons, so to make things easy, I'm going to steer clear of anything greater than 5 Earth masses. To my surprise, this eliminated 16 out of the 20 candidates, leaving us with only 4 terrestrial worlds to examine. Gliese 367b, Gliese 486b, LHS 3844b, and L168-9b. While this certainly helps narrow things down, I still can't name 4 planets. So now let's take a closer look at each of these and see if we can find the best of the bunch. First up, we have Gliese 367b, a planet with half the mass of Earth. This would put it somewhere between Earth and Mars in terms of size, which, considering those are the 2 most habitable planets in our solar system, paints a promising early picture of, what was it, Gliese 367b? A planet like this, orbiting in the place of Earth, would certainly be capable of holding on to a moderate atmosphere and more. But, well, 367b doesn't have an orbit like the Earth's, but rather sits far closer to its parent red dwarf star. So close, in fact, that it takes less than 8 hours to make a full trip around, what takes the Earth 1 full year, qualifying this as one of the nearest orbits ever observed. This nearness allows its star to bombard the planet's surface with over 500 times the radiation Earth receives, enough to overpower even a strong magnetosphere and boil away any atmosphere. From just the few data points we have, the image emerging of Gliese 367b already seems like one hostile to life. To me, this appears more like a Mercurian body, or that is to say, what happens when a perfectly good planet flies too close to the sun. So I think I'm gonna let somebody else name this one. Though come on, Icarus is the name we're all thinking, right? I mean, I know there's already a star called Icarus, so name this something like Icaria or Icarion or something, I don't know. All I know is that I'd rather take my chances with the other 3 terrestrial planets. Next up, we have Gliese 486b, a notably larger planet weighing in at 2.8 Earth masses. And I don't want to jinx it, but things are looking good again. This gives 486b a radius of 1.3 Earths, which, if my memory serves me, is thought to be the ideal planet size when it comes to habitability. This almost ensures it's big enough to sustain a liquid metal core, where molten iron can flow in a never-ending convection current, enough to generate a substantial magnetic field. With this barrier protecting against radiation, outgassing volcanoes would almost assuredly blanket the planet in an atmosphere. Already, even with this very limited information, Gliese 486b is looking more promising than the last planet, which is probably why this was among those chosen to have its atmosphere analyzed by the James Webb Space Telescope, which only makes me more confident in its prospects. If this assumption proves true, and by some miracle Gliese 486b has a notable atmosphere, suddenly the possibility of liquid bodies on its surface becomes real too. Whether that's liquid water like on Earth, liquid methane like on Titan, or some other compound entirely, the presence of any liquid bodies would no doubt be a substantial find, and something I wouldn't mind giving a name to. Of course, there's also the possibility that the planet could have too much of an atmosphere, one that plunges its surface beneath miles upon miles of dense vapors, trapping even more heat on its surface than the exposed side of Icaria, Gliese 367b. The only way to figure out which side of the coin Gliese 486b falls on is to take a closer look at it, which is exactly what the James Webb Space Telescope is for, leaving its odds of being notable at best a toss-up for now. So I'll keep it in mind, but let's continue. Next up, there's LHS 3844b. At first glance, we'll find a very similar story to the last. An almost identical radius of 1.3 Earth radii make this on paper another ideal world to investigate. That's probably why Laura Creedberg et al. Did just that in 2019 by searching for signatures of atmospheric heat redistribution in its thermal phase curve. In doing this, Laura found a high fluctuation between hot and cold heat signatures, implying one side of the planet experienced severe heat and the other cold. Telltale signs of another tidally locked planet without so much as an atmosphere to moderate its temperatures, again likely making this a very similar world to Mercury. Despite its size, LHS shows all the signs of being another dead world, proving that even the most promising planets can still be ruined by the nature of their parent star. Without an atmosphere, I'm gonna say its chances of harboring life are next to none, so I'm gonna pass on this one too. That finally brings us to L168-9b. Here we'll find a mass 4.6 times the Earth's, qualifying this as a bona fide super-Earth, by far the largest terrestrial planet receiving a name this time around. This almost assures the presence of an atmosphere, though beware, just like the rest of these, L orbits exceedingly close to its red dwarf star, causing many of the same issues such as tidal locking and high degrees of solar radiation. But being such a large planet orbiting so close, I'd say the biggest risk L runs is actually having too strong of an atmosphere, turning this world from a super Earth into what can only be described as a super Venus. All in all, that leaves us with 16 gas or ice giants and only 4 seemingly terrestrial options, 2 of which lack any atmosphere and 1 has too much of an atmosphere, leaving us with really only one halfway decent option, Gliese 468b. While its size certainly makes it Earth-like, it's important to remember that habitability is a tricky line to walk. And so until we get a closer look, even this could still end up being nothing more than a solar wind-swept wasteland all the way to a greenhouse nightmare. Though according to the transitive property, somewhere between those two extremes, there must be a narrow range of moderate conditions, which I'm hoping is where this planet eventually falls. However, even in the best of cases, this planet would still be a tidally locked, radiation-laden world. Now, I've spent a lot of time thinking about environments like this, and the conclusion I've come to is that these aren't really conducive to life. In fact, there may only be one scenario I can imagine where a planet like this could still be a home, and it needs water. Lots of it. So much that the entire rocky surface submerges under oceans miles deep at their shallowest, turning the planet into a fishbowl, a super aquarium. Now, while this might sound crazy, water is actually one of the most abundant compounds in the universe, making it very possible for planets to have way more water than we're used to. In fact, there are already moons like Ganymede, Titan, and Callisto that contain more water than all of the Earth's oceans. So all it would really take to flood the Earth's surface in a similar way is a collision with a Ganymede-type object. While I'm not saying Gliese 486b is definitely an ocean world, what I am saying is, hey, maybe it could be. If so, the mega ocean's currents would act as a vital temperature regulating system for the planet, where warm water from the day side flows into and mixes with the cold waters from the night side, mediating the temperature extremes that come from tidal locking. The depths of an ocean like this would also act as a barrier against radiation, helping to shield any and all organisms swimming in it. All of this has been to say that while none of the options presented have really been promising, there is at least one way I can imagine one of these being habitable. Of course, by the time we know whether or not this is actually the case, its name will have already been selected. So we don't really have a choice but to name this planet before we know anything more specific about it. Keeping our limited understanding in mind, now comes the fun part, coming up with that name. The way I see it, the best strategy for me to increase the chances of my name being the one that's accepted is to first read all the rules and make sure I follow them to the T. First, the proposed names should be of things or places of long-standing cultural, historical, or geographical significance worthy of being assigned to a celestial object. And okay, this is a good one. That's how I like my names anyway. Meaningful. So I have no doubt that I'll be able to find a name that's worthy of Gliese 486b. The next rule is, although not necessary, the names may be drawn from themes related to the sky and astronomy, or okay, yeah, it would be nice to have an astronomically related name, but in the description it says that's not necessary, so we'll keep it in mind. The third rule is that 2 names should be proposed, one for the exoplanet and one for the star it orbits. Okay, interesting, we're naming 2 things instead of 1. That makes things more fun, actually. Next up we have indigenous names. In recognition of the United Nations Decade of Indigenous Languages, speakers of indigenous languages are encouraged to propose names drawn from those languages. Okay, well, I don't think this one really applies to me. Next, we'll read naming theme. The proposed pair of names for the exoplanet and its star must follow a common naming theme. The naming theme describing how the names are related in some logical way. Okay, that makes sense. Keep the 2 names related. Though I'm not sure that needed a whole new bullet point. It kind of feels like it could have been included in this one up here, but sure, I'll keep the 2 names related. After that, there are just a bunch of specifics on like entry formatting and whatever. So those are really the only rules. Come up with 2 related names worthy of being planets and stars. Now all that's left to do is find the right name. And honestly, this is something that I really struggled with. Probably because I wanted to find the most perfect name ever. Something so good that it was guaranteed to be selected, and nothing less would do. So I hit a bit of a wall at this point. It turns out just coming up with the most perfect name ever for a place we know next to nothing about is pretty tough. But finally, after reading the rules 1,000 times over, I realized that if the IAU really wants names that are meaningful, then what I have to do is find something that's meaningful to me. And I know it sounds crazy, but the entire time I spent making my optimistic visuals for an ocean world, I couldn't help but think of another video I made on my other channel, Astro Pro. You see, this summer I spent a lot of time going into the hills around me collecting fossil imprints from the bedrock, which offered us a glimpse into the many primitive animals that lived here 400 million years ago when this whole area was underwater. These animals, like crinoids, echinoderms, archaeocyathids, bivalves, brachiopods, they all represent not only some of the earliest animals, but also occupied some of the most basic ecological niches available in the ocean, feeding off the organic matter suspended in the water. This strategy for survival likely persists wherever ocean life dwells, leading me to think these are at least some of the types of alien sea life we might expect to find in an environment like this. And while this gives us some names to choose from, that's still a problem because we only need 1, or I guess 2. If you watched the video though, which you should, it was a really interesting one, you'd know there was only one kind of fossil that I was hoping to find but didn't, a Eurypterus. The reason behind this becomes obvious with a look at their fossils, which are big enough to tell you that they were a lot more active than many of their contemporaries. Sporting legs for swimming, eyes for spotting prey, and wielding huge claws for hunting, these were some of the best adapted and most complicated organisms to arise at this time, allowing them to briefly reign supreme as the apex predator in many ancient animal communities. Being top of the primordial food chain, however, naturally means there were far fewer Eurypterus than, say, your average sponge or star, making their fossils exponentially harder to find, even here in New York, where the very first ones were uncovered. Since making that video, finding a Eurypterus fossil on my own has become one of my biggest personal goals, which I feel like in its own way is another search for alien life, given that these sea scorpions lived and died out over 400 million years ago, before anything even resembling a human came around, on an as of yet unnamed planet, very different from the one we inhabit now, making a Eurypterus about as foreign to us as any life we might find in space. Altogether, this is what makes me confident Eurypterus is a name worthy of a planet like this. Eurypterus, Eurypteria, Eurypteron, whichever one sounds more planetary, really. For now though, I'll stick with Eurypterus, so let's review. Is a thing of long-standing historical and I'd say scientific significance, considering without it, our understanding of one of the Earth's earliest ecosystems would be not only incomplete, but actually missing its most important character, making it absolutely worthy of being assigned to a celestial object, if you ask me. Next, while not necessarily drawn from themes relating to the sky or astronomy, this name is super related to biology, ecology, geology, and really all of the natural sciences, which I consider to include astronomy, as it's equally based in observing the world around us. Plus, this wouldn't be the first thing in the sky named after crabs, so the precedent is already there. Next, oh man, here we go, 2 names should be proposed. You all thought I forgot about this one, didn't you? Don't worry, after the very first Eurypterus fossil was found here in New York, other specimens were uncovered in places like Estonia, Scandinavia, Great Britain, and Germany. Over time, as the Europeans and Americans compared their findings, they realized each one had subtle differences in their sizes and morphologies, hinting that Eurypterus wasn't a single animal, but a kind of animal, a genus, which all of these creatures belonged to as their own species. The kind of Eurypterid found here in New York that started it all became Eurypterus remipes, which, if you ask me, is a good enough name for a star. It means something in Greek, probably. Just be glad it wasn't Eurypterus pittsfordensis or Eurypterus hinningsmoni or Eurypterus tetragonophthalus that was found here. So yes, we have two related names, done and done. Finally, is Eurypterus in any way part of an indigenous language? Well, no, it's actually from a language that was never even spoken here. But okay, hear me out. Eurypterus remipes was first found in Oneida County, New York. Oneida being the name of the nation that was here before being, colonized and all that. So hey, if Eurypterus ends up having like moons or continents or any sort of notable features, that ought to be the first name they use. Which means, hey, would you look at that? I've covered all my bases. This name is good to enter into the contest. Now all that's left to do is actually do that. This is where you all come in. If I learned anything by reading every inch of this website, it's that the one thing the IAU wants more than anything is community outreach and engagement. They want to get people excited about astronomy, which I hope I've done a good job of today, because I think that's my one true advantage in all this. I have an engaged community excited about astronomy. So here is really a once-in-a-lifetime opportunity for everyone watching to directly participate in astronomical history. If you liked the name I came up with, gee, thanks. I'd sure appreciate it if you'd tell the IAU that. But if you don't and think you can come up with an even better name, then, well, go right ahead. There are 20 planets getting names. If yours is good enough, it could win too. Whatever you do, just get involved. And who knows, maybe you and me both could end up naming exoplanets.